All right, so 9, 1, 2, and 3 are all conics. 9, 1 is circles and parabolas. 9, 2 is ellipses. 9, 3 is hyperbolas. So we're gonna do this one between today and tomorrow. We'll finish tomorrow, but we'll start at least with what's a conic. So a conic section for or what we call just a conic is the intersection of a plane and a double napped cone. So a double napped cone is that thing that looks like the hourglass. If you take a plane and you slice through it horizontally, it creates that perfect circle. If you do it at an angle, it creates that oval shape, which is called an ellipse. If you cut off just the tips of it, it's the parabola. And if you slide through vertically, it's the hyperbola. So all of these things are formed by sliding a plane through what's called that double napped cone. The first thing we're going to do is a circle. So by definition, a circle is the collection of all points that are equidistant from a fixed point. So that point in the middle, which is your center, to any point on the circle would be equidistant. That like distance is the radius. The standard equation, so you're going to get this for each of the conics. The circle has one standard form. The rest all have two. Okay, but a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. So first of 4 different kinds that you're going to need to know. So example 1 says point 1, 4 is on the circle whose center is -2, -3 as shown in the figure. Write the standard form of the equation of the circle. So I know the equation for my standard form is x minus h squared plus y minus k squared equals r squared. And I know I need to plug in for the h, the k, and the r. So what information do you already have? Good. Center is -2, -3. That's my h and k. So I would get x minus a -2, which becomes +2. So the sign always changes. Plus y minus a -3, which becomes +3 squared, equals r squared.
Are x and y the 1 and 4?
Good. So there's a couple different ways to find your r squared. One is, and I think the easiest, what I would recommend, is if they give you another point, make that point your x and y. And then when you plug those in, you'll only have r as your unknown and you'll solve for it. So now I'd make 1 plus 2 squared plus 4 plus 3 squared equals r squared. So I get 3 squared plus 7 squared equals r squared. 9 plus 49 equals r squared. And r squared is 58. If it had asked for the radius, I have to square root it. But it doesn't. It just wants the full equation, which means I literally use x plus 2 squared plus y plus 3 squared equals 58. Another way to find the r is find the distance between the center and the point. That would represent your r. But I would say that people make mistakes when we start getting into the square roots of that stuff. So I would recommend the method we just used. Questions so far? All right, example 2. Now we're putting an equation into standard form. So to do this, we have to complete the square. If you remember your complete the square, right, we first are going to group together our ax. So if I have ax squared plus bx plus c equals 0, then to complete the square, we group together the ax squared and the bx terms. We bump the c to the outside. If there's something on the front of the x squared term, we have to take it out. So I would take out the a. And I would get x squared plus b over a would be the result there. Leave the space to fill it. You remember this? We would take that second term, divide it by 2, and square it. So this gets divided by 2 and then squared. And we'd add it here. And we'd add it to the other side of the equal sign. And then it will be a perfect square trinomial, and we will factor it. The difference is, like we did this quadratics, we did this back in chapter 2. We did it a long time ago. When we did it, you only had one squared term. How many do you have if you have a circle?
Wait, would you add that to the c or add it to
No, I would actually, we're going to bump the c to the other side because this c is your constant. We're going to bump it to the other side, and then we'll balance it out by adding it to the left and to the right.
Okay.
Because you have to do it twice. You have to do it for the x term, and you have to do it to the y term. So when I've got a circle, the first thing I'm going to do is group together the x squared and the x term. I'm going to leave the space. Then I group together the y squared and the y term, leave the space, and I bump the 6 to the other side. Ladies, focus, please. And then I take that second term for each. First of all, if there was something attached to the x and the y, I'd have to factor it out. There tend to not be that very often with circles, but it can happen. If it is, it's going to be the same number on the front of both. Then I take the second term and I divide by 2 and square it. I ignore the sign because I always square it, and if it's positive or negative, it's always going to become positive when I square it. So I take the 6, I divide it by 2 and square it. 6 divided by 2 would be 3. 3 squared is 9. I add the 9 inside the parentheses, and I add the 9 to the other side of the equal sign to balance out my equation. Then I'm going to repeat the process with the second parentheses. I take the negative 2. Don't worry about the sign. 2 divided by 2 squared is 1 squared, and that's 1. I add the 1 to the left, and I add the 1 to the right. Everybody with me so far? All right, then to factor, so I'm going to come back up here so we can talk about that again. Factoring a perfect square trinomial. I square root the first term. I square root the last term. I take the sign from the middle. Put it in parentheses and square it. So that's the shortcut. The squared's going to show up in a second, Nate, if you want to wait. Wait for it. Wait for it. There's a squared missing from the outside of the last. I wrote it. I mean, as long as you want to remember that it's there. There it goes. Okay, parentheses get squared. So that's once we complete the square, then we'll factor. So if I go back to what I just completed the square on, I'm going to factor each of these. So for the x's, I square root the first term, that's an x. I square root the last term, that's a 3. I take the sign from the middle, which is minus, put it in parentheses and square it. Then repeat it for the y's. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. And then on the other side of the equal sign, I'm going to combine those together. So negative 6 plus 10, which gives me positive 4. So what's the center? Good, 3, 1. And what's the radius? Square root it, right? That's r squared, so 2. If it asks you to graph, I think on the website you're going to graph it, then we just plot the center. So I would go 1, 2, 3, 1. And then my radius is up 2, right 2, down 2, left 2. And I just do the best circle I can do, okay? On WebAssign, some of the graphing is annoying. Remember, you don't have to graph it on WebAssign. You can graph it by hand in Notability. That's fine. In order to graph a circle, you have to do the middle and a point on the circle, which is kind of annoying unless you can go perfectly to the right, up or down the radius, but you also could just graph it by hand. Questions on either complete the square or circle, because we're going to complete the square today, tomorrow, Tuesday, Wednesday. Like, it doesn't go away. It's through all of the conics. Okay. Example 3 says find the x and y intercepts. How do I find intercepts of any graph? So if I want to find the x-intercept, what do I make 0? Good, y. And if I want to find the y-intercept, my x is 0. So let's do the y-intercept first. Or sorry, let's go in the order that it asked. Let's do the x-intercept first. So I'm going to make y 0. X minus 4 squared plus 0 minus 2 squared equals 16. X minus 4 squared plus negative 2 squared equals 16. X minus 4 squared plus 4 equals 16. X minus 4 squared would equal 12. And then when I go to square root it, what do you got to remember to do? plus and minus. So I get x minus 4 equals plus and minus the square root of 12, which becomes 2 root 3. And then I would add the 4. Remember, our intercepts we list as coordinate points. So my y is 0. My x is 4 minus 2 root 3. And 4 plus 2 root 3. Good so far? Okay, now I gotta do y-intercept. The y-intercepts, I make the x 0. So 0 minus 4 squared plus y minus 2 squared equals 16. Negative 4 squared plus y minus 2 squared equals 16. 16 plus y minus 2 squared equals 16. Subtract the 16 from both sides. And I get y minus 2 squared equals 0. So two things can happen here that didn't happen the first time. A scenario like this where it's 0, there's no such thing as plus or minus 0, right? So if I square root it, it's just 0, which means there's only one y-intercept. The other thing that could happen is when you go to square root the other side, it could be negative. So what happens if I try to square root a negative number? It's imaginary, which can't be graphed. So that's when you would say there's none of that type of intercept. If it was I was trying to find my x-intercepts and I got the square root of a negative number, there's no x-intercepts. If it was y, there's no y. There could technically be neither. If you think about like a circle that's in my top right quadrant, it's never going to touch the x-axis or y-axis. So it's possible for a neither scenario to happen. It's possible for there to be two of each, one of one, two of each. There's all those different combos that could happen. Angel.
So I get that there's no plus or minus 0, but how come the plus or minus doesn't carry over to the 2?
Because it's what you bring the square root into that comes with the plus or minus. So this cancels with this one. It's when we bring it to the other side, when we bring in the square root, that term gets the plus and minus.
Okay, that makes sense.
Questions so far? All right, we're going to start parabolas. We'll finish this tomorrow. But parabolas are the second conic. So a parabola is the set of all points, x, y, in a plane that are equidistant from a fixed line, which is called the directrix, and a fixed point, which is called the focus, is not on that line. The midpoint between the focus and the directrix is the vertex, and the line passing through the focus and the vertex is the axis of the parabola. So here you've got your typical parabola, okay? But when we do this in chapter 2, we talk about things like their intercepts, the vertex. We find the vertex using negative b over 2a, right? Like we did that kind of stuff. This time around, the most important parts of a conic parabola are the vertex, the focus, which is inside the scoop, whether it's up, down, right, or left, it's inside it, and the directrix, which is either a vertical or horizontal line that's in the opposite direction. So your parabola cannot pass through your directrix. It always goes the other direction. Where it opens up or down, or horizontal now. They could open right or left. The difference is which term is squared. X squareds are up or down. Y squareds are right and left. Here are your, I would say just know that, wait for it, the top ones. The formulas for the standard form of the parabola. These top two are if the vertex is not at 0, 0. Which is probably going to happen more than the other way around. So you might as well just remember those, because if I plug in the 0, 0 for the h and the k, it goes away. The bottom is just if there is a vertex at 0, 0, then you don't have an hk. But these are technically the same equations. Now notice a couple things about this. When we do parabolas in conic form, the squareds are usually on the left. It doesn't really matter left or right, but what does matter is that 4p value, so the value that is on the front of the second side here, cannot be on the side with the squared. So it's on the side with the non-squared term. The way I remember it is that a squared term already has something outside the parentheses. It can't have two. So if it's in parentheses and squared, it can't also have something on the front. It has to be on the other side. So if I had something like 16y squared equals x, wait for it, I cannot leave the number in front of the squared term. I'd have to move it to the other side. I'd have to take and either divide by 16 or multiply by 1/16 and rewrite that as y equals 1/16 x. So there can be nothing on the front of the x squared or y squared. The HK is your vertex, and 4P is the value that's next to it. P represents the distance from the vertex to the directrix and the vertex to the focus. All right, so this is what they look like if they're vertical. You've got on the left-hand side, you've got the parabola. And then your focus is P units above the parabola, if it's a vertical parabola that opens upward. And the directrix is P distance below. So in both these cases, the distance here and here are the same. So distance from vertex to focus is the same as distance from vertex to directrix. The only thing that changes for the second one is now the directrix is above it and the focus is below it. So this one would have a negative 4P and this one would have a positive 4P. So if the one on the right, negative, the one on the left, positive. If you're and that's if your x is squared. So if x is squared and it's a positive 4P, it goes up. If x is squared and it's a negative 4P, it goes down. And then on the right-hand side of your slide, now you've got your horizontal parabolas. These are when the y is squared. When the y is squared and it's a positive 4P, it points to the right. Negative 4P, it points to the left. But again, distance from the vertex to the focus or vertex to the directrix is still the same value. It's still P. All right, so example 4 says, find the standard form of the equation of the parabola with the vertex at the origin and the focus at 0, 4. All right, so vertex at the origin and focus 0, 4. I'm a visual person, I have to draw it out. If you want to try to figure it out in your head, you do whatever makes the most sense to you. But usually silly mistakes happen when you do that. So my advice is draw it out. Doesn't have to be perfect, but at least give yourself an approximation. So vertex at 0, 0, because that's where the origin is, and a focus at 0, 4, 1, 2, 3, 4. So if my vertex is at 0, 0 and my focus is at 0, 4, what direction is my parabola going? Up. And if it goes up, which variable is squared? X is squared. And is my 4P positive or negative? Positive. Now, I have my vertex, I know the direction, right? All I need is the value of P. How do I find P? Distance from?
It's times 2.
If I do, so distance from just the vertex to the focus is your P. If you do directrix to focus, then you have to cut it in half. But from here, whoops-a-daisy, wrong color. From here to here, which is 4, that is your P. So now my equation is x minus h squared equals 4py minus k. My h and k are both 0. So this is x squared equals 4. I'm going to plug in the value of p times y. And we just said p is 4. So my equation is x squared equals 16y. K is 0. Yeah, because it says it's at the origin. So they're both 0. Same thing for B. Vertex is at the origin. So my vertex is at 0, 0. And this time it says the focus is 1, 0. So that means my focus is here. Vertex is here. Which direction is this parabola facing? To the right. And if it goes to the right, what variable is squared? Y. And is it a positive or negative 4P? Positive. So I already know that the k and the h are 0, which means this is y squared equals 4 times p times x. And this time, what's p? 1. The distance from the vertex to the focus is 1. So I get y squared equals 4x. Not terrible, right? Yeah.
How come it was the y squared in front?
Because it's pointing to the right. So it's got to go around the focus, and if it does that, then it's a y squared. Yep. and to the right would be positive 4p. If it went left, negative 4p.
P, if it's in the X, it's only, like if P is in the X, it's only the, like by units in the Y-axis, how you determine.
Correct. Yep. Okay. One more and then we'll call it quits for today. So find the standard form of the equation of the parabola with a vertex at 1, 3 and a focus at 1, 5. So I've got a vertex at 1, 1, 2, 3. Here's my vertex. And my focus at 1, 5. So what direction is it facing? Up, which means which one gets squared? X squared, positive or negative 4p? Positive 4p. This time my vertex is not at 0, 0, right? So I get x minus h squared equals 4p y minus k. And my hk is my vertex, which is 1, 3. So x minus 1 squared equals 4. I'm going to come back in and fill in the p. Y minus 3, because that's my k. And then what's p? 2, the distance from my vertex to my directrix, which is 2. And I get x minus 1 squared equals 8, y minus 3. Oops.
You don't have to like
Distribute it? No, you actually don't want to. Good question. If it is distributed, you have to take it out. Like if it said x minus 1 squared equals 8y minus 24, you can't have these two next to each other. You have to take them out, which is what's going to happen when we get into completing the square on the parabola. We'll save that for tomorrow. Questions? Okay, so if you